Hi, I'm Sabella Hunter. This is going to be my Unit 2 project for geometry, and I'm going to go over two examples for two Unit 2 problems. So, for the first one, line segment AB and line segment CD are not parallel. Is it possible for the segments to have each of a given number of angles formed? If so, sketch an example. So for part A, for 0 angles, that is not possible. And if you're wondering why, it's because two line segments have to make at least one angle. So for A, we put no. For B is asking us if we can have one angle. Well, as you can see here, if we put line AB and line CD together, we have one angle. So for B, we would put yes, and we would sketch our angle. So for C, it's asking us if we can have two angles. Well, we can put a straight line like here and have another line coming here. You can do this in a bunch of different ways, but I just have it like this. So you have one angle here, and for C, we would put yes, and we could sketch it like this, or we could have it like that, or that. But for D, because we cannot have three, because we only have two line segments. If we had three line segments, then well, we still couldn't. So no. The minimum number of angles you could have with two line segments would be either 2, like we have here, or 1. So for E, it wants to know if we can have 4 angles. Now having two angles intersect, or if they were perpendicular, you could have 4 angles. Yeah, so 1, 2, 3, 4. 4 angles. So we put yes. Okay, and so we are on to the second problem, which wants us to complete the 2-column proof. It gives us information in this section, which is the given, which is angle 2 is congruent to angle 3, angle 1 is complementary to angle 2, which means that they make up a 90-degree angle, shown here, and angle 3 is complementary to angle 4, which means they make a right angle here. And it wants us to prove that angle 1 is congruent to angle 4. So it wants us to see if this angle is congruent to this angle right here. So we have our statements on this side. We have to find the reasons on this side. So part A, we have angle 2 is congruent to angle 3. Well, let's stop and think for a little bit. You see we have up here, angle 2 is congruent to angle 3, and we have it here too. So for this reason, it's because it's given. because it's given. I'm having a few technical difficulties. Please excuse me. Given. For part B, we have the measure of angle 2 is equal to the measure of angle 3. So, it's saying that this measure, the measure of this angle, and this angle, they are equal. So, they are exactly the same. They are symmetric. So, we would put the symmetric property of equality. Property of equality. Yeah. Yeah. And the symmetric property of equality, it's just saying that if A equals B, it's just saying that if A equals B, then B equals A. So next we have angle 1 is complementary to angle 2. So saying right here, this is a 90-degree angle, and it's also saying that angle 3 is complementary to angle 4. So it is also saying that this angle and this angle make up a 90-degree angle. So, and if you also notice that this same exact information is up here. So we would also put this as the given. The given. So next up we have the measure of angle 1 equals the measure of angle 2, 90 degrees. And the measure of angle 3 plus the measure of angle 4 is 90 degrees, which is why it's complementary. So, for this one, the property of it would be the it would be the angle. It would be because the two angles are complementary. Yes, equal 90 degrees because they are complementary. So for E, we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. Yes, so as you can see, this is congruent to this. They both equal the same things if you were to add up their measures, which would be 90 degrees. So it is basically saying the same thing as the symmetric property of equality. So you would actually just put the symmetric property of equality. Okay. And so, for part F, we have the measure of angle 1 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 4. Well, what happened to the angle 2 that was in here? So, if you notice, looking back up at the given information, that angle 2 is congruent to angle 3. So we would be using the substitution property of equality, which is basically just saying that if A equals B, then A plus C is the same thing as B plus C. Okay, so now we have the measure of angle 1 equals the measure of angle 4. Well, what happened to the angle 3s that were up here? They were subtracted from they were both just subtracted from both sides of the equation. So that's how they disappeared. So for this one, we would have the subtraction property of equality. And you don't need to memorize them all, but it helps if you make a chart or a note of each of them in your notebooks. So this last one, angle 1, is congruent to angle 4, which means it is pretty much the same thing as this one. This one is not given though, but they are symmetric. We have found out that they are symmetric, so we would just be using the symmetric property of equality. And there you have it. We have finished. I have shown you how to do those two problems, and if you were following along and you should have done them correctly, then give yourself a star. Thanks for watching. Bye. Yeah.